Alright, so today we just got to go over the last bit of factoring and dealing with special cases here. So first up is a difference of squares. When we talk about our squares, we're talking about perfect squares here. So 1, 4, 9, 16, 25, 36, 49, 64, that kind of thing. So the first thing you'll notice on these, like with x squared minus 9, okay, there's no x term, and that's because it's a 0x. So this is going to factor into x minus 3 times x plus 3. Okay, and that's going to be your final answer here for this one. Because when you multiply it out, you get x squared plus 3x minus 3x minus 9. 3x minus 3x is 0x. It's not there in the answer. Same kind of deal here with x squared minus 25. We go x minus 5 times x plus 5. Again, final answer. You have x squared plus 5x minus 5x minus 25. Right there's your 0x again. Down here, x minus 1 times x plus 1. Again, if you want to check these out, go ahead. X minus 12 times x plus 12. The order doesn't matter if you want to have x plus 12, x minus 12, that's fine. But we haven't done any of these where you have a coefficient on x squared other than 1. All the coefficients of x squared so far have been 1. But I want to do a couple with these difference of squares. You have 4x squared minus 25. Square root of 4 is 2. We're going to factor this into 2x minus 5. 2x plus 5. That's your final answer there. Again, if you multiply that out, you're going to get 4x squared plus 10x minus 10x minus 25. Right there's your 0x, okay? And then on this one, it's going to go 3x plus 4 times 3x minus 4. Again, the order doesn't matter, just as long as they have opposite signs. Final answer would be 9x squared minus 12x plus 12x minus 16. Again, there's your 0x for a final answer of 9x squared minus 16. Right back to where you started. Okay, so there's no x term because the coefficient on x is 0. That's what happened. So next up, we have these perfect square trinomials. We're going to have a special way to write these. But this is like the stuff that we did originally. We're looking for factors of 25 that add up to 10. So it's going to factor into x plus 5 times x plus 5. Okay, because when you multiply that out, you get x squared plus 5x plus 5x plus 25. And right there's your 10x. But since we have two x plus 5s, we're going to write our final answer as x plus 5 squared. Just like that. Same thing here. Factors of 36 add up to 12, except that it's going to be subtraction here because we need a negative 12x. So x minus 6 times x minus 6, whereas x minus 6 squared. Then this last one, factors of 81 that add up to 18, 9, and 9. So x plus 9 times x plus 9, whereas x plus 9 squared. So same kind of stuff that we've been doing, just have a special name, and we're going to write our answer like this when we have two identical binomials. These ones we're going to factor out a GCF first. So I'm going to factor out a 5 here. 5 divided by 5 is 1. You're left with x squared. 45 divided by 5 is 9. Now you have a difference of squares. X minus 3 times x plus 3. Okay. Last up here, 24 and 50. Your GCF here is going to be 6. We're going to factor out a 6 and get 4x squared minus 25. So you get 2x minus 5 times 2x plus 5. All right. So you have a Schoology checkpoint for today, and then that's it. Have a good day.